Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0452 signifies an issue with the fuel tank pressure FTP sensor circuit, specifically indicating low voltage. The FTP sensor is a crucial component located on or near the fuel tank that monitors the pressure inside the fuel tank. It plays a vital role in the vehicle's evaporative emissions control system by helping ensure that fuel vapors are properly contained and managed. When this error code is triggered, it may indicate that there is insufficient voltage being supplied to the sensor, which can cause the engine control module, ECM, to misinterpret the fuel tank pressure readings. This situation can lead to increased emissions and may result in the vehicle failing an emissions test. In your troubleshooting efforts, it's imperative to follow a systematized method to accurately diagnose the problem and avoid unnecessary part replacements. The fuel tank pressure sensor, FTP sensor, is essential in managing the vehicle's fuel emissions. Its primary role is to detect the vapor pressure inside the fuel tank, helping the vehicle's engine control unit, ECU, optimize fuel efficiency and reduce emissions. Located typically on the fuel tank, often integrated with the fuel filler neck, the FTP sensor requires proper voltage to function effectively. If the sensor fails, not only will it trigger DTC P0452, but it may also lead to further complications such as engine performance issues and increased environmental emissions. Properly understanding the location and function of this sensor is vital for effective troubleshooting, enabling quick identification of where issues may be occurring in the vehicle's emissions system. Several factors can contribute to the triggering of DTC P0452. A faulty FTP sensor itself is often the most direct cause. It may in turn fail to send correct voltage signals to the ECM. Additionally, poor electrical connections can impede the flow of voltage, resulting in an erroneous reading of the sensor's performance. Loose or corroded terminals, especially at the FTP sensor and the powertrain control module, PCM, can drastically affect signal integrity. Furthermore, a damaged wiring harness or broken insulation around the wires can lead to shorts or open circuits, which may result in low voltage readings. It is crucial to thoroughly inspect these components before proceeding with replacement to ensure a correct and economical repair. When the DTC P0452 is triggered, several symptoms can present themselves that indicate a problem with the fuel tank pressure sensor. The most immediate symptom is the illumination of the check engine light on the vehicle's dashboard, signaling that a diagnostic issue needs attention. Drivers may also notice decreased fuel efficiency due to improper fuel management caused by inaccurate pressure readings. An important consequence of this issue is the potential to fail an emissions test, especially if the vehicle has stringent emissions control measures in place. The eventual risk includes increased environmental pollution, as the vehicle may not effectively contain or manage harmful fuel vapors. Understanding these symptoms helps prevent long-term damage to the emissions system and possible legal complications from failing emissions regulations. Begin the troubleshooting process by turning the ignition switch to the on second position, or by pressing the engine start-stop button to achieve the on mode. This action allows communication between the vehicle's onboard diagnostic system and the diagnostic tool utilized for reading codes and data. It is crucial at this stage to record all freeze-frame data, which provides a snapshot of the vehicle's conditions at the time the DTC was triggered. Furthermore, reviewing general troubleshooting information specific to the DTC P0452 can offer valuable insights on potential issues related to the fault code. This preliminary information will serve as a foundation for informed diagnosis as you proceed through the troubleshooting steps. Next, utilize the Honda Diagnostic System, HDS, to clear the DTC P0452 from the vehicle's memory. This step is vital in establishing a clean starting point for the diagnostic process, ensuring that any observed codes after clearing will be due to a current issue rather than residual data. After clearing the DTC, it's important to monitor whether the same code reappears in subsequent diagnostic checks. Observing the vehicle's behavior after this step may give indications of the FTP sensor's condition. By using the HDS, technicians can perform further analysis, accessing live data to enhance their troubleshooting strategy and solidify conclusions made during diagnostic testing. Following the clearing of the DTC and monitoring its status, turn the ignition switch to the lock, 0 position to ensure that all systems are deactivated. This action is necessary for safety and to allow for the next diagnostic step, which involves removing the fuel fill cap. Removing the fuel fill cap is essential because it will normalize pressure readings and prepares the FTP sensor for accurate data collection. This step emphasizes ensuring that the fuel tank is vented properly before proceeding further with testing, as excess pressure or vacuum can yield faulty sensor readings. Ensuring these preliminary actions are executed correctly paves the way for more accurate diagnostic outcomes. With the fuel fill cap removed, turn the ignition switch back to the on position or press the engine start-stop button to enter the on mode again. Utilize the HDS to assess the FTP sensor within the data list. At this point, you will be looking for specific pressure indications that should be about -7.3 kilopascals, -2.16 Inchinger, -55 millimeter Inchinger, or a voltage reading of 0.3 volts or less. These readings are crucial. They inform whether the FTP sensor is functioning within spec or if a fault condition persists. Accurate monitoring of these values can help determine the next steps in the troubleshooting process significantly. Once the FTP sensor readings have been recorded, examine whether the output is close to -7.3 kilopascals. If the readings indicate this value or below, including 0.3 volts or less, proceed to step 10. This implies that the sensor is providing a misleadingly low signal that might suggest a fault in the FTP sensor or its connections, meaning you will address this in the subsequent step. Conversely, if the readings are higher or inconsistent, head back to step 7 to investigate further. This distinction in readings will guide which particular avenues of troubleshooting are necessary to accurately target the issue at hand. In this troubleshooting step, you will need to reinstall the fuel fill cap securely back onto the fuel tank. After ensuring that the fuel cap is properly seated, start the engine and allow it to idle. It's essential to give the engine sufficient time operating at idle so that the onboard diagnostics can adequately assess the system's conditions. During this idling period, closely monitor the onboard diagnostics OBD status for DTC P0452 using the HDS. The OBD status will provide crucial information regarding whether the DTC has failed or passed, indicating the effectiveness of the troubleshooting steps taken thus far, as well as the operational status of the FTP sensor and related systems. After monitoring the OBD status, determine if the HDS Honda Diagnostic System indicates a failed status for DTC P0452. If the HDS displays this status, you are to proceed to step 10 to investigate further into the potential causes of the failure. On the other hand, if the HDS indicates passed, it is possible that the issue is intermittent. In such cases, Check for loose connections or poor terminals at both the FTP sensor and the powertrain control module, PCM. These simple adjustments may resolve the false alarms and prevent the DTC from recurring. Keeping a meticulous check on the connections is crucial for ensuring long-term operational reliability and accuracy of sensor data. For the next step, turn the ignition switch to the lock 0 position to ensure that the system is completely powered down and prevent any electrical shorts during the diagnostics. After that, disconnect the FTP sensor's 3P connector. This step is essential in isolating the sensor for individual testing, allowing for a focused investigation into the sensor's functionality. Disconnecting the sensor will enable you to test its performance without interference from the vehicle's systems. Proceeding at this stage with caution and ensuring proper handling of electrical connectors is vital for maintaining the integrity of both the sensor and the vehicle's wiring systems. Once the FTP sensor is disconnected, rotate the ignition switch to the on position once again, or press the engine start-stop button for the vehicle to power on. The next move involves using the HDS to check the FTP sensor data. You will be looking for the same critical pressure readings, approximately -7.3 kilopascal, -2.16 inches of mercury, -55 millimeters of mercury, or a voltage reading of 0.3 volts. If the values meet these specified parameters, it may indicate a successful sensor disconnection without any additional faults present in the circuit itself. If they are outside of this range, you will have to move to step 14 to investigate deeper into potential wiring issues or sensor faults that still require resolution. Evaluate the readings from the FTP sensor again. If the readings indicate around -7.3 kilopascal or below, proceed to step 20. This confirms that the FTP sensor is likely in good working condition, and the issue may lie elsewhere in the circuit, potentially in the power supply or connections. However, if the readings differ significantly from these values, you need to advance to step 14 to conduct further tests that will encompass the voltage measurements across the FTP sensor's connectors. This careful evaluation of the sensor voltage will aid in identifying whether the sensor itself is faulty or if the circuitry is the root cause of the problem. Now, you will measure the voltage at terminal number 3 of the FTP sensor's 3P connector. This terminal is typically connected to the vehicle's voltage supply line and should reflect the voltage the sensor receives from the powertrain control module, PCM. Compare this voltage reading against the body ground to confirm if it falls within the acceptable thresholds. This action is vital as the discrepancy in voltage levels may suggest either a fault in the FTP sensor or in its wiring. If the voltage is indeed low, it may indicate that there is a grounding issue or an electrical fault preventing the sensor from operating correctly. Subsequently, this examination will guide further troubleshooting efforts towards either a wiring repair or sensor replacement as deemed necessary. After completing the necessary repairs or sensor replacements indicated by previous diagnostic steps, it's crucial to conduct a final verification process. Start by rechecking for any DTCs using the HDS to ensure that DTC P0452 no longer appears. If all systems are operating correctly, the DTC should be absent. Additionally, make sure that all electrical connections, especially at the FTP sensor and PCM, are secure and corrosion-free, as loose connections can lead to recurring issues. Finally, a test drive of the vehicle is crucial. This allows the onboard systems to reevaluate the pressure readings under various driving conditions. This final verification ensures that any repairs made have successfully resolved the fault and that the system is functioning optimally. To prevent future occurrences of DTC P0452, Establishing a routine preventive maintenance schedule is vital. Regular inspections of the FTP sensor should be part of this maintenance. This includes checking for any signs of wear or damage to the sensor itself and its associated wiring harness. Equally important is monitoring all electrical connections linked to the FTP sensor and PCM. Addressing any loose or corroded terminals can save significant repair costs down the road. Additionally, a thorough check of the entire emission system can help ensure that other components are functioning correctly and efficiently. Proactive maintenance heightens the longevity of components and reduces the likelihood of unexpected failures in the future. In conclusion, the DTC P0452 is primarily related to the functioning of the FTP sensor, a critical component in the vehicle's emissions control systems. Understanding the importance of the FTP sensor allows for more effective troubleshooting and repair actions. Following a systematic approach in troubleshooting will help in accurately diagnosing the issues, rather than resorting to guesswork. Furthermore, establishing a habit of regular preventive maintenance can significantly reduce the frequency of such error codes from arising. By ensuring the sensors and their connections are consistently monitored, the overall performance and reliability of your Honda Odyssey are enhanced, contributing to optimal vehicle operation and emissions compliance. Please like and subscribe to the channel. See you next time.